first event of the Spring Design Lectures 2006, presented by the American Institute of Architecture students. Matt, Tim, and I would like to thank the Undergraduate Student Center for funding the program, the AIAS, CSI, and Tau Sigma Delta organizations for co-sponsoring. Mazel Soccer produced video, and Ike Yanni produced our website. Special thanks goes out to John Fleming, our advisor, for guiding us through this process, and additional gratitude goes to the many members of the university and professional communities who have given us their support and assistance. Tonight's speaker is a graduate of the University of Pennsylvania, recipient of the Rome Prize, and a fellow of the American Institute of Architects, and a partner of Timberlake Architects in Philadelphia. He has taught, lectured, and served on juries internationally, and has received innumerable honors and awards for his work. His work engages issues of industrial processes, modular systems, innovative manufacture, and mass production. Research into new materials and methods is central. The built work realizes these new ways of thinking and doing, practical expressions of potential futures for architects, designers, and builders. Far from being just novelty or technophilia, the work exhibits the strength, directness, and sure sense of materiality that are the enduring hallmarks of good architecture. Please welcome James Timberlake.
Is this on? Yes. Okay. Let's get this arranged here. Just give me a second here and look at this. Can somebody adjust that? It seems a little, the mic seems a little hot. Is that too loud for you guys? Is that all right? Okay, good, thanks. Dan, thank you for that introduction. I'd like to thank Dean Fawn, who I've known for 10 years, 12 years, ever. And it's so great to see him here. You're very lucky to have him. And I think great things will happen. Already are happening at the school. I had a wonderful tour through the sort of precursor exhibit, some of the student work for the accreditation tour, and there's some spectacular things in there. I was very impressed by that. It's really great to see wonderful work. This lecture is about an hour and 15 minutes long, and I say that because I know the penchant for people to kind of look at their watch and wonder where the pretty images are, and then split for dinner, if not beer. And so I was a student once. I've done that too. And so I just let you know that I'm going to introduce this talk a little bit through the first few slides. And I want to talk a little bit about some of the principles and the theory behind what we do. And then I want to show you 4 projects, 2 of which are recently through, well, one's going into construction, the other one we're currently being considered for. And then the last 2 projects I'm going to show you are just recently completed and photographed. Steve Kieran and I call this toward an ethical aesthetic or architecture. Partly because I think for the last 21 years, since 1984, since we've been in practice, we've been trying to find a way to work and a method of working and a product from our work that we believe is deeply rooted in a kind of ethic. That ethic, I hope, will become clearer as you see the work. We wrote an essay about it in the recent World Architecture, which has been sent to a number of copies of which is published in China, so it's not readily available here. It is in English. It's not just in Mandarin. But I think we may have sent a copy to your library here, and if we haven't, we will do so. But we talk a little bit about what an ethical aesthetic is in that particular essay and in that monograph on our work. About 4 years ago, we published a book called Manual, and again, I don't know if this is in your library, but it was called Manual, The Architecture of Caed, Timberlake, and it chronicles the first 15 years of our work, a process of that work and the aesthetic that came from that process. We wrote it for all of you. We didn't write it for us. It's not, while there are, we think, wonderful pictures in it, it's not a big glossy book, but it really talks about our process and our process with clients and with our consultants that allowed us to do the kinds of details and designs that are chronicled in that book. There's an essay by Alberto Perez Gomez in there that we were very grateful for, and I think he talks about our craft aesthetic in there, and so I was flattered to follow that little short video clip at the beginning that talks about using your hand and your mind and your eye, that you are a craftsman and then an artist. I thought it was quite compelling. Some of our early work that's in that book, Manual, are just shown here. I'll just briefly flip through these. This is a project from 1987 done in the undercroft of a Catholic women's college, a little student center project, a renovation. And one of the things that we tried to do when we were little, a small firm, we're now 54 people, when we were just Steve and me and a few other people practicing, was always look, when we got a commission, was always look for an opportunity in that commission. It isn't always readily present to you in the commission or in what the client hands to you, particularly at that scale and at that level of aspiration of client. But what we try to do is find an idea, find an opportunity, find a way of working and thinking that can be expressed in the work. And as we worked through different scales of projects, this was our largest project up through about 1992, a science building at Rider University in New Jersey. We always tried to bring, a kind of promise of an idea and a methodology of working to these particular projects. This little pool addition to an old chicken coop that was renovated into a house in Chestnut Hill, Pennsylvania. Really, it takes a kind of exoskeleton approach to a pool house, inverts the process inverts the kind of formality of that chicken coop and turns it inside out and expresses it in making the pool house addition and brings that out into the landscape and into the lawn. The Westchester University Student Union project, completed in about 1994, again expresses a different series of materialities, a concrete structure, an exposed frame, a different arrangement of spaces in that particular building than we had explored to date. And by this particular time in our career, at about the 10-year mark in our career, we had done at least one of every kind of basic structural system, tried a variety of materialities, really looked for ways of bringing, natural light and these materials together in our spaces, and used each of these projects as experiments for ourselves while trying to meet the client's objectives. This little middle school, actually lower school gymnasium, the pods, the little boxes on the window boxes on the side of the gymnasium. I don't have an interior view here, but they provide these little places of respite for lower school children, these places that are intimately scaled. They only come up to my, about my neck, and they're only about this wide. So, two kids can kind of crawl in there and call that cubby their own without, really feeling as though an adult would violate that space. And then, of course, they occupy the inside and the outside. The steps are out on the playground. So, again, they're sort of child-sized, a place that, formally, allows them to perch, while people are occupying the playground. A recently completed project at the University of Pennsylvania that has been, I think, widely published and you may be aware of. As we have moved throughout the next, 5 to 10 years of our work, I think one of the things that we have been very interested in, and I know that Dan asked me about this, is really about the idea of integrated component assemblies and the idea that you can take systems and combine them in unusual ways and really begin to have things like walls become mechanical systems and lights and mechanical systems and electrical services and walls all become integrated and potentially built even on site. In this particular case at the University of Pennsylvania, this was the first active curtain wall in the United States, a triple glazed wall with an interior chamber that is actually attached to the mechanical system of the building. Air is drawn through this wall and it becomes a tempering barrier to the outside. It also allows us to make for a much more transparent building. And in this particular case, since it was one of the first buildings that the University of Pennsylvania built in the 21st century, this looked at a post-tension concrete structure with flat plate construction with the columns pulled off the exterior and the curtain wall expressed so that this could be eminently mutable or changeable over the next 100 years. And here is a view through the curtain wall. It was off-site constructed. These units that you see being lifted into place on the left-hand side are, the unitized constructed panels, all 3 layers of glass, the frame, the gaskets, the electronics for the blinds and the blinds, all contained within that panel, lifted up into place. They were 4'4" by 14 feet high and 7 feet by 14 feet high. On the right-hand side, you see the triple chambered, pressure equalized elements in a plan view looking down toward the clip that is hung off of the post-tension slab, embedded in the slab. And then a second unit is brought to that, and gaskets are sort of flap gaskets are what keep the water from entering those chambers. And if they enter those chambers, those 3 chambers, to the right-hand side of the unit, there's a vertical channel that allows the water to get out of those chambers. And it just allows for abundant natural light, and it allows for a very transparent structure to the outside. And of course, we're very proud of this building because of its environmental characteristics and its environmental responsibility. This view you can't see anymore. It's now been blocked by a building designed by Todd Williams and Billy Shen, which is under construction, and they will face one another across a courtyard. Another project that represents a tangible example of the amount of research that we do in our office. This is called Smart Wrap. This was a view of the installation at the very first Solos exhibit at the Cooper Hewitt National Design Museum in New York. And what this was a speculation on the building envelope of the future. The idea that perhaps we can take an R15 wall, conventionally built out of block and steel and brick and an air chamber and insulation, and with looking at new materials, thin that up in a membrane that might have printed technologies on it that is eminently flexible, eminently replaceable, and eminently mass customizable. And so this pavilion was a demonstration project of that, of those first prototypes. You're looking at simulated wrap, printed wrap up above, the different colors representing the different materials on the wrap. And then this view of my son, who was then 5, looking through through the wall, looking past the photovoltaics, which are the dark rectangles, the thin film batteries, which are the light green rectangles, and the OLEDs, the organic light emitting displays, which are the yellow panels. But if you imagine for a moment, if you just kind of close your eyes for a moment, and you imagine a wall all out of OLED, in other words, a wall that looks like that screen right there, that it enables you to put an image up on the wall, allows me to plug my computer into that wall, and rather than going through that projector, it allows me to put the image up on that wall directly. Just like your cell phone, that little 2x2 lighted screen on your cell phone is an organic light emitting display. It allows, it emits light, emits color, emits information that comes through digitally. If you imagine that whole panel being yellow rather than that little dot, that's really our imagination of this particular wall. That whole buildings could be wrapped with this, or even wrapped with whole walls of photovoltaics that are organically printed on plastic wrap. It's eminently environmentally sustainable and ethical because the PET is recyclable and the organics on there can be washed off and treated before they go into any kind of waste stream. How do we get to this particular point? Well, and how do we produce the kinds of things that we're currently doing? And how do we get to those kinds of research projects that we're working on? We have 4 people working in the office on full-time research. And how do we get to these projects such as Yale University's Pearson College renovation? You'll see the sister college in a little while called Davenport College, which is on the opposite side wall of this stairwell wall that you see on the left-hand side. They literally, the 2 colleges kiss one another. We renovated both and punctured that wall so you can see students moving through the 2 colleges differentially. How do we get to this level of craft? How do we pull it off in this day and age? Well, there's a big difference, as you might imagine, between intention and realization. And this is something that you're not going to learn in architecture school. You're going to learn this when you get out into the world of practice. And not everything that you draw gets built. We were just talking about this before I began the lecture about how buildings get executed with multiple committees and different kinds of input. And then you have to also get it constructed. You have to work with a contractor or a CM. And those CMs are being asked, and their subcontractors, hundreds if not thousands of people being asked to interpret the drawings that are on the left-hand side of this image into the reality that's on the right. And how do we get from one to the other? Well, it's a very, very arduous process, as you can imagine. And one of the things that we've tried to do is understand how one fails in this process so that you can understand how you can succeed. And one of the ways that architects fail at this process is that we're losing control of the process. We've removed ourselves from control positions of design and of construction. And so this chart right here chronicles the kind of outcome of loss of control. Essentially, declining productivity. The idea that you're with less control, we're losing productivity. Whereas in a highly controlled environment like all other non-farm initiatives or industries, there's a great deal of control. They're highly productive and they get a great deal of results from them. One other way that we're losing control of our projects is just compare these two projects right here. That science building I showed a little bit earlier, built in 1992, and a building that we renovated at Princeton University called Little Hall, that was originally built in 1899 and 1902, respectively. And just look at the building systems. Many of you are going through a building systems project right now in your studios. Look at the building systems in 1899 and 1902 that Cope and Stewardson, the architects from Philadelphia, had to work with in that building. Basically, the HVAC system was open your window. The heating system was put a log in the fireplace. And the bathrooms didn't exist. You went down the stairs, you went outside to an outhouse that was adjacent to the residence hall. So only about 5% of the fabric of that structure had any kind of systems within it. But compare that 1992 building where nearly 50% of the architecture in that building is other systems. Systems that you and I don't necessarily have direct control over. We have consultants, we have multiple layers of consultants, we have multiple layers of outside contractors that have to feed into making those systems and pulling them off well. So one of the concerns that we have with that is that we need to gain control of it. We need to know and understand those systems and really know and understand how those systems come together and really have a better understanding as designers and architects about those systems and what they mean. We're also giving ground to attorneys. And this is not an attorney bashing lecture. This is just one comment about two different kinds of contracts. The contract on the left is a contract that Steve and I lifted from one of Frank Lloyd Wright's documents with a client. And the one on the right is one of the current AIA documents. And I'll just read for you what the highlighted piece says. The AIA contract, the Personal Architectural Services of Frank Lloyd Wright, says, the architect undertakes to itemize millwork and material for the building, lets contracts for piecework, and eliminates the general contractor, where possible, by sending a qualified apprentice of the AIAS and fellowship at the proper time to take charge, do the necessary shopping, and hold the whole building operation together, checking costs, layouts, etc., and endeavor to bring the work to a successful completion. Now compare that with the AIA contract, our national professional entity that I am a fellow of. Item 2.6.6 says in the contract, the architect shall not have control. It says it in black and white, shall not have control over or charge of, and shall not be responsible for construction means, methods, techniques, sequences, or procedures, or for safety precautions. Steve and I say bunk. We say nonsense. We've told that to the AIA, and we tell that to you. We believe this contract does you guys and us no good when we go out and field and build our buildings. And we believe Frank Lloyd Wright doesn't quite have it right because I think he's a little naive in this day and age of litigation. But frankly, one of the lessons that we need to learn about all of this is that we need to take risks and have control over our process. Then there's what we call the otherness of designing and making. And you just take two, call them craftsmen or artists in this particular case. Brunelleschi, built 500 years ago, was the architect, the builder, the product engineer, the building systems and material scientist, and he was the master builder for the Duomo in Florence, for the dome in Florence. Versus, he had great control, deep control. He designed the systems, the materials, the brick, the way the brick was going to get up to the cupola and the dome, brought the workmen there, supervised the workmen, ensured that his drawings were followed to the letter. Take, for instance, Man Ray's speculation in 1929, his piece, which nobody could find, by the way, of a piece that he decided to phone in, basically the otherness of control. The idea that what he was doing was he was going to design something, and he was going to speak to another person, and he was going to say, here's what I want. And he was going to hang up the phone. And whatever was on the other end was the translation of that artist through the medium of the telephone, and through the medium of hearing, and translation of that other person on the other end to whatever Man Ray had in mind. And so there's two different levels of control here in terms of deep control. And then we're now also operating in this world what we think is a new client mandate. We chronicle this in our book, Refabricating Architecture. It's not about quality times scope equals cost times time. I'm not sure that any of the students here have really learned that equation, but you'll learn it soon enough. Quality is how well something is built. Scope is the program. Cost is the amount of money that it takes to build it. And obviously the time is the amount of time that it takes to build it. And for 100 years, architects have been working with the idea that equation needs to be in equilibrium. If you imbalance cost or scope or quality, you need to either reduce time or increase cost or do something else with the scope in order to bring the whole equation under balance. It's the automobile industry and several other industries over the last decade that we chronicle in Refabricating Architecture that have really looked to an imbalanced equation here. Improving quality and increasing the amount of scope in automobiles and ships and in planes and places like that, while maintaining cost and time in the making of the product going forward. We're finding that our clients, our architecture clients, are demanding that of us as well. And so we've got even greater pressures on ourselves in terms of how we're making our work. We have old and new legal structures, ones that cut the architect out of direct conversation between the client and the contractor, where the new models are really more linear and more seamless. So how do we get to where we want to be? Well, one of the first things that you'll do when you go into practice is really think about how you want to design your own culture. And the two images on the lower part of the slide are our culture, the culture that we're currently in, that we've been in for the last 3 years, an office that we moved into. That's a big loft space where everybody is on wheels. There are no partitions. The partitions that are in there that make our conference spaces are incredibly, mutable and nimble. We can move people around to meet, client needs and allow us to kind of resource differently. But further, one of the things that we've been working on through our research efforts is really to think about the 4 principles. And these are taken from a variety of places. Kind of kaizen, Japanese principle of continuous improvement. To plan, then to do or to make, to monitor what you do, and then to learn from what you do, and to continue that cycle. And while you're doing that, to continue to design and innovate and invent while we make these things. And there's some risk involved in that, but the risk is managed through the monitoring and the learning in the process of planning and doing. We also collaborate. We also feel we have a responsibility to collaborate. In Refabricating Architecture, we talk about why we think the world of architecture is in the place that it is right at the moment. The left-hand diagram here shows the separated worlds that we're currently working. Contractors in one quadrant, architects and consultants in another, material scientists and product engineers in another, rarely collaborating, rarely speaking to one another. The world we envision is the one on the right, where architects move back to that center of control, like Brunelleschi, where they've got deep control over the process of making things, the integration of systems and materials, and the consultants in the design process, so that those 50% of the systems that are in your building that aren't pure architecture design, but come from HVAC, come from MEP systems and structural systems and data and power and all those other things that we can make architecture out of, are now back in the control of what we make. Furthermore, we've tried to practice this. We've tried to practice these kinds of collaborations. And in the upper left, we collaborated with Skanska and a number of other people on the making of DuPont and ILC Dover, the maker of NASA spacesuits, on the making of the Smart Wrap project. We worked with a company called Egg Rock to make factory-built bathrooms, the prototype of which went into a project at Cornell University. And we've continually asked ourselves how to work on each and every project rather than and redesign the collaborative model for each and every project as we move forward. What that allows us to have is we're not master builders any longer, but we have master control. We have thousands of bits that go into projects, and we have lots of drawings that we have to do. We have lots of things that we have to coordinate, and we can't have singular control over them. We have to use collective intelligence in the making of our buildings, and that's how all of these bits and all of these pieces come together into something that we can be satisfied with when we're through with the process. And while we're doing that, one of the things that we need to do is be environmentally ethical. We need to be thinking about how our buildings return to the earth, how they come from that place and how they're going to return to the earth, and to keep that in mind. And that's been a principle of our practice for the last 21 years. Now, I just show you these organizational diagrams because I think there's just a little more theory, and then I'll get on to the pretty pictures. But the point of showing you this is that you have to have a holistic model about how you work in order to keep design and innovation and invention in balance. And the whole principle of why we exist is really to kind of design and innovate and invent. But it's through a kind of research core that we do that. And what allows us to allow that research core to happen in our office is that all the other things that operate a business, the workplace environment, the technology that everybody uses in our office, the marketing and public relations efforts, the ability, to maintain finances and staff and all of that, really are in balance and they're in equilibrium, so that we can concentrate on those core principles of designing, innovating, and inventing. That research core allows us to do a variety of things. We look for different project opportunities and new worlds to work within. And it looks for ways to, through grants and other ways of collaboration, what we call OPM, or other people's money. Competitions and grants and research opportunities that enable us to bring different kinds of work into our practice and integrate it in the culture that's within our office. And that research kernel then, if I animated this diagram, this Venn diagram, which this isn't, but we have an animated version of this. Sometimes we're doing lots of architecture and a little bit of planning and notebooks, and sometimes we're doing books and some planning and a little bit of architecture and a lot of research. And this research kernel pollinates and sifts through all of the kinds of things that we do as an office, and becomes the kind of seminal aspect of what draws all of these things together in a kind of cohesive whole. Lastly, one of the things that we do when we talk about learning and we talk about monitoring, we have a management system as well. We just became ISO certified 2 weeks ago. What is ISO certified? It's the International Standards Organization, usually done with industrial products and industrial systems. But there are only a handful of architects in the world that are ISO certified. Grimshaw is one, Foster is another. We're one of the first architects in the United States to be ISO certified. What this allows us to do is to integrate that research and to use quality principles that are embedded throughout the work that we do. and draw that through our work so that young architects can understand our culture about how we design and how we want to work and what we want to produce when they come into our office. It streamlines our ability to educate young architects and train them for IDP and registration. And it allows these quality principles to come out into the work that we build. That left-hand document is a kind of chronicle, just one of the 39 processes that we've mapped in our office. But what it allows us to do is eliminate the kinds of discrepancies and gain the control over the work that you saw in those images that are on the right-hand side of Pearson College. So we get from idea to form, or from intention to realization, through the aegis of these kinds of principles and systems that we've got embedded in our office. Now, the process of a project in an office takes a variety of tracks. And it doesn't always it's not always linear. And I don't know how many of you have tried to think about your own design process and to try and map that. But I suggest that before you leave school, you have some idea what your own process is of designing, so that when you get stuck on a problem, you can really understand where and how to back up and move forward. One of the things that this does is really chronicles how projects travel through our office. The kind of grid in the middle are the 4 quadrants of realization, recognition, specialization, and education. And the project inception of these particular projects, such as Refabricating Architecture, our book, where does it begin? Well, it began in the kind of education quadrant. Began because Steve, Karen, and I teach at the University of Pennsylvania. We taught at Michigan and other places. Out of those design research laboratories that we've led, have caused us to think about different ways of building, different ways of making things, and it caused us to, go get some grant money through the Latrobe Fellowship, a research grant through the American Institute of Architects. It instigated us to write a book and realize that book and then bring it back into the world of teaching and publication and so forth. And as you just flip through the rest of these, the prefabricated bathroom models, these off-site fabricated integrated component assemblies, really began in this particular case from a discussion about integrated component assemblies, on a very small scale, at a talk and a lecture, going through some speculation on whether or not we can pull off these integrated component assemblies and these off-site produced modules, getting hired by DuPont to actually prototype using some of their materials, some vanities and bathrooms, and then taking it through the kind of recognition and back into realization such that these vanities are now in 4 different projects at Yale University, off-site produced bathroom modules, and 1 prototype up at Cornell University in their projects. Off-site produced residential modules that were built at Yale University. Again, the track looks a little like a hurricane track through the Gulf, beginning with a kind of provocation by a client, the realization that they needed 32 new beds in a landlocked site in a courtyard at Yale University. How were we going to build there? We couldn't get conventional constructors in on that particular site without airlifting a bunch of material in, and they didn't have time to get it done in the amount of time. So we speculated on how they might do that. We brought that out publicly. We educated ourselves and others in the process, and then it takes on other kinds of tracks. Building information modeling. We're currently using Revit in our office, a building information modeling system, the next level beyond AutoCAD, 2-dimensional drawing systems. We're using Gary's digital technologies project, and we use a variety of other modeling softwares to look at things things three-dimensionally, like Rhino and Form Z and 3D Studio Viz. And we have a three-dimensional printer in our office as well that allows us to three-dimensionally print models in real time, so that we can utilize those in the design process with our clients. Researching systems such as constructed wetlands for a middle school down in Washington, D.C. The Levin Hall active curtain wall project, again, a different kind of track of research and speculation. And then, of course, the Smart Web project, where it begins and where it ends. And these are the kinds of things that really cause us to ask ourselves questions about each and every project that comes in, set ideas and goals for those particular projects, and then try to track them as we move through those individual projects. And then, of course, the Loblolly House, which I'm going to show you here. And it's one of the 4 projects that I think we feel are really beginning to kind of change the boundaries of how not only we're thinking, but how we hope others will think. This is a completely off-site produced house that's being done. It's 2,500 square feet for a house in Maryland. It overlooks the Chesapeake. It sits amongst these tall loblolly pines. It's very, very tall, thin pines that have a kind of top kind of canopy to them. And it sits in a wetland because it's very near the shoreline of the Chesapeake. So it has to be up on stilts. And what you see in the left-hand plan is a diagram of pilings where the cars can pull underneath the kind of platform and it pushes the building up on stilts. You enter through a kind of walkway over a constructed, the bottom level of an impluvium, which you'll see in a minute, that comes through the house. And you walk across that walkway and then up the stair, which is on the right-hand side of the right-hand plan, and arrive at the kind of first level of grade, which is actually a master bedroom and a child's bedroom, separated by that impluvium in the plan, which is right about here. So you come up the stairs, enter, and get into the bedrooms through the portal here, or you can continue up through a stair that takes you up to the next level, up onto the living room, dining, kitchen level, and then there's another study and bath up on the upper level of that. There's a green roof up on the top of the house, and I'll talk about that in a minute. This is a view of those pilings as you enter the house, coming under the cover of the house overhead, up through the stairwell, past the impluvium, open to the sky. A view through that impluvium, that rainwater capture point in the house. That's part of the sustainability agenda of that house. And then a view from one of the bedrooms, looking out through a triple glazed wall that part of which is a nano-wall system that opens out to the Chesapeake with screening windows and storms, so that it can be buttoned up during the winter, looking out to the Chesapeake. It'll have expansive views to the south and to the east. These are 3 views on the right-hand side that show 3-dimensional models done in Revit, which integrate all the components in one drawing of that particular house, showing the systems opening and closing on the right-hand side, and then 2 of the models that we sent to the 3D printer, again with the systems open and closed on the site. Now this is where I want to kind of spend a little time. This house, this is an exploded view of all the components in that house. And all the components in that house are off-site constructed. the only thing that we're building on the site, and we have to bring a pile driver there on a barge, float it in, drive the piles on the site, is really the only way we're touching that site. The road already exists, but we wanted to disturb those sites as little as possible. So all the rest of this material is going to get either trucked or barged to the site. The frame is a Bosch Rexroth extruded aluminum frame like you saw in the Smart Rack Pavilion in New York. That's this piece at the core of the diagram in the center right here. The floor systems are custom designed cartridges which include mechanical systems, data, and electrical systems in a wood structure that are being built by Benson. And then the wall systems are also being built by them. The exterior window systems on either side are being provided by yet another supplier. The green roof is now being grown on site, being grown off site in trays, which Frank Lloyd Wright actually did copper trays for falling water on part of that house. These are coming in PET trays that are grown off site and then lifted up onto the roof. And all of these systems come together in about 3.5 weeks over the course of a moment in June. And this is ultimately a view from the Chesapeake that you'll see of that particular house. One of the things that we believe that both in integrating component assemblies, but also in off-site producing work, is really to try and figure out a way to get an environmentally ethical architecture that we can touch the site a little bit, less stridently than we do when we're building a building on site for 16 to 18 months. But also be able to control the waste streams in the product delivery methodologies of building. And because by doing it in a manufacturing setting, we're not just throwing that stuff in a dumpster. Nearly 25 to 35% of all brand new materials that come to a new construction site end up in a waste stream in a dumpster on a project. Architecture is immensely wasteful, folks, and we need to do something about that. And we think that one of the ways we can do that is design a system and design a way of working with contractors by building a system. And we've actually tracked through this whole supply chain to this particular house and who the assemblers are on this house and how that's all going to come together, and logistically work with them on the scheduling for this particular house so that these things come in real time and in just-in-time delivery methodologies, so that nobody's sitting around waiting for things to come together. It'll come together like we expect, a car to come together. The next project is one that we recently completed that we very much hope will be a commission of ours at Stanford University for the School of Medicine. And oftentimes the program brief that a client gives you looks a little bit like this. This is our diagram, our interpretation of their program. But basically, what the dean of the School of Medicine asked us to do was look at how medicine can translate, he used that word, translate the ability to understand medicine from the education process, from their research process, and from their care process, all through the aegis of redesigning an educational system that was going to be manifested in a new building on the Stanford University landscape. And that whole idea of translational learning or translational knowledge really is all about inverting the process of how we learn, basically. It's basically turning a building inside out. It's not housing students in opaque rooms and closeting them away, but in this particular case, is getting paths of travel from the hospital, from the School of Medicine, from the research elements in the School of Medicine, all crossing paths with one another through a kind of core element, in this particular case, a building that they wanted to put on the campus. Now the campus, if anybody's been to Stanford, is quite beautiful. It's in Palo Alto, California. Major, the original core axis and campus was right here. And that inner quad, that original inner quad, was a group of buildings loosely, well, actually rather tightly interconnected by a series of arcades and loges that actually allow all the buildings to interconnect. But because of the landscape there and the climate, all the buildings are essentially open to the outside. You can get from one building to the other by going outside rather than going through buildings. And that is part of the kind of DNA that we used in the making of our Learning Knowledge Center project. So our master plan for this School of Medicine and the Institute of Medicine is up above the Science and Engineering quad in this sector right here. This building right here, and I'm kind of circling with my arrow, was done in the late 50s and early 60s by Edward Durrell Stone. And it was loosely based upon, I think, Corbusier's Venice Hospital proposal, a series of interconnected walkways and courtyards that are kind of gridded out in a Cartesian way, with open spaces and closed spaces, all interconnected visually by a system of walkways. And that kind of was, again, a loose interpretation of that inner quad diagram, if you kind of track it back a little bit, sort of Durrell Stone's idea about how the inner quad was really made up. When we looked at that and looked at their master plan, we took it up yet another scale, and the idea that landscape, these kinds of courtyards, these kinds of open spaces, and the ones on the interiors of buildings are the ones that really make up the kind of DNA of the School of Medicine campus. So you have different levels and intimacies of landscape and building working together seamlessly to make educational spaces both inside and outside of buildings. Now, a couple of the other significant buildings on the campus, the CCSR, Cancer Research Institute, designed by Norman Foster in the early 90s. Basically, two kind of slab sheds, sort of salt-like, in a kind of sliding juxtaposition with a major walkway, outdoor walkway in between them with a shading device overhead. And then a brand new building by Norman Foster, which is right here, which actually is a kind of precursor to what we think the Learning Knowledge Center ought to be, which brings the landscape directly in from the outside, brings it into that kind of hourglass-shaped courtyard, which you can't see very well in the diagram, but brings it inside, turns the building transparently inside out. So the inside is very transparent, the outside retains all of Stanford's terracotta and sandstone coloration. And so our initial speculations on this really looked at how we might introduce a relationship between landscape and inside and outside, and explored ways of organizing the building through a series of flat plates and trays. And these are four examples, four options that we, in an initial meeting with them, we showed a series of flat plates and trays with kind of mutable, changeable inside walls that reach out, back out into the landscape and connect inside and outside through great deals of transparency, abundant natural light, and other shading devices. In order to convince them during the presentation phase of this that we knew Stanford University and we understood the kind of characteristics that really make up Stanford University and then make up our building, these next two slides track through what we call the DNA of Stanford. Across the top is the core campus, the original academic campus, the loggia, the portal, what we call the umbra, the Italian word for shade, and the material color. the medical campus, the kind of translation of that on the medical campus, and then what our building did with those kinds of elements. And we did that, you know, with the courtyard, the LA, the Grove, and the comment that I said about the inside-outside relationship with the spaces there. Rather than being in the Northeast or in the Midwest, you know, where climate changes are rather extreme, it just gets hotter in California from about 52 degrees all the way up to, you know, occasionally in Stanford around 100 degrees. And so groves of trees and shading areas and outdoor courtyards that are naturally ventilated are very much a part of the making of the spaces. Then we tracked through a series of their existing pathways, open spaces, road networks, and so forth. And then took those diagrams down through the master plan that had been prepared for them. And then we showed them how we were adjusting that master plan into our own speculation on the lower tier there. And this is the plan that we presented to them. A plan that is tied together via a very kind of large interior school medicine walk. It's outdoors, but it's interior to the school of medicine. The school of medicine is separated by this campus drive here. This is Foster's building right here. And this walk goes right through Foster's building, right down to what we were imagining were a series of buildings that might replace their institute buildings with a series of new buildings that would have the kind of DNA of our speculation carried throughout their master plan, making these larger outdoor landscape spaces here and here, integrating them into the buildings and bringing those landscapes into the building via outdoor courtyards and outdoor spaces. The Learning Knowledge Center actually engaged the landscape in two ways, and you'll see this in a moment. One by a slightly raised lawn that sloped up to the second level, and then a sloping lawn that went down to the lower level of the building. So this courtyard here, right here, sloped down to the conference center and the lowest level. This walkway, the Via Medica, right through the middle here, I lost my arrow, right through here, got you to enter at the ground level. And then this sloping lawn brings you up to the second level. So now we have a true crossroads. We have pathways going down, going across, and going up. And this building then is also driven deeply into the Edward Durrell Stone building up here, through connections at the lowest level and at the second level as well. Now I won't take you into all the program, but the program shows these connections and shows these relationships between connections to existing buildings and how we would go ahead and make those spaces, and then how the circulation of these spaces would wrap around essentially the outside of these interior closed spaces that are open to the outside, that are brought inside to outside, so to speak. So here you're standing at the campus drive at a major crossroads between Sarah Mall and what's called Via Ortega, which is this path leading up the right-hand side toward the Edward Durrell Stone building. On the right side is our image of Foster's Clark Center building. The Durrell Stone building at the back distance, and we drove a portal, you know, into the Durrell Stone building, so that walk goes right into there, and that's where we would have located the dean's office. And then the Learning Knowledge Center is the building you see is a series of trays with a very large roof shading device and an open courtyard cutting it to the left-hand side. That raised lawn over a vivarium, there's a building below this raised lawn that exists. And the way we would build that raised lawn up is basically through foam, you know, lightweight foam, building, you know, an understory, and then, you know, 3 feet of soil, and, you know, which is stabilized and sides, or retaining wall on the left-hand side here. We're working with Hargraves Associates on this particular landscape. And so this walk takes you up to the upper level entry, which takes you into the second floor, which gets you over to Beckman, the building on the left, and back into the Edwards Durrell Stone building on the right. And then you begin to have this exposure of these learning knowledge centers, which are highly computerized learning environments that are free-form, highly mutable spaces, but need controlled light, separated by these more transparent spaces, that can be classrooms, meeting spaces, and other kinds of spaces as well. See the connection in the right-hand Durrell Stone building. Here you see the sloping landscape going down to the conference center, and then the open tray of space that kind of cleaves the building above the second level into an open courtyard on the upper level. So the building gets progressively open as it opens up. This is the major connection between lowest level, main level, and upper level, major public stair that's outdoors and open, and a walkway that takes you across the Edward Durrell Stone building and a kind of low shed that walks across the building. And then the learning environment, this is called the Exploratorium, not our work, which is a series of interactive spaces where scientists, researchers, medical people, and students and faculty alike can come together and work collaboratively in the ground floor environment, but it's also a place where visitors can understand what the School of Medicine and the hospital and the Research Institute are also all about as well. The model that we produced basically shows three-dimensionally the first, the Learning Knowledge Center here and the landscape around this, the first school of the Institute of Medicine building, which would replace a building that gets taken out here, which I'm not showing you. And then our addition of the Institute buildings later on, which complete the building. This is a view at the upper level looking down into the Exploratorium and kind of that upper level courtyard, which allows light to drop down into that space, and views out into the Stanford landscape. And then a view at Via Ortega and Via Medica showing this Institute of Medicine building further down in the distance, the raised landscape and the interconnection visually and extended through by these landscape groups that would draw through the building. Now let me show you two things that we've built in detail that, just to kind of show you a kind of broad range of the kinds of work that we do, and how the language gets drawn across, very, very different kinds of buildings. We've done 5 different college renovations at Yale's divided up into colleges. They're residential colleges. You live, you eat, you do some study in those residential colleges. You get general classroom and other graduate school work in the graduate schools. And so people leave these spaces and then come back to these spaces on a daily basis. And they're roughly housing somewhere between 350 and 500 students in these colleges. And these colleges, the majority of them were built starting in about 1927 and finishing in about 1937. 5 of the 7 of them were designed by James Gamble Rogers in a very kind of eclectic style, from collegiate Gothic, very heavy stone buildings, through these very lighter, thinner Georgian brick red and white buildings. And we've done them all. We've renovated all of them. Comprehensive renovations. They go out of circulation, we move all the students out, tear out all the systems, replace windows, replace roofs, basically do all the systems repair for the next 70 years and rebuild these buildings for the next 70 years. And the landscape was redone, working with a local landscape architect in New Haven. But one of the things that we tried to find, if we showed you, like if we chronicled all of our residential college renovations up at Yale University, one of the things that you would find from Berkeley College, through Pearson, through Davenport, then into Silliman, and the other colleges that we've done there, is, excuse me, one of the things that we try to do is find ways of introducing simultaneous histories. How to get, people to understand that these buildings were built in this case, 1935, and retain the highest and best qualities of those historical characteristics while not being overly slavish to them, while introducing a new history, a 21st century history, a contemporary history into this renovation that embeds it in a way that people understand that this is a living, working, learning environment that's very much vibrant and alive, and not just a kind of museum that people are living in. So here is one of these insertions trying to get light into an undercroft, which used to be a basement, which is now found program space that we help find that's drawn through the building. This is one of these living histories that basically gets a very light hand, a restoration hand, a kind of clean the paneling, paint the ceiling, relamp the lights, but don't muck it up. I think we don't have to show the hand of design here. One of the things that we have to do is be good neighbors and leave it well. And then those simultaneous histories get changed slightly because of systems integration, and historical libraries like this get a different kind of ceiling, but a kind of new history of light drawn into them, natural light drawn into them, and so forth. But the real new history is found in these undercrofts that connect both Pearson and Davenport, which used to be storage spaces, basically, or unused, basements that were basically found by us, and when they needed to get common spaces, places to teach, places to study, places to recreate, and so forth. We hunted down these basements in all of these residential colleges and tried to figure out a way that they could get reintegrated into the spatial life of the college. And so in this particular case, the way we did that was by introducing a major public stair, which you can see in this image, coming down to that lowest level. And then the simultaneous histories are, understanding what the materiality of that undercroft was. In this particular case, stone rubble foundation walls, which we've uncovered and stabilized, and then inserted this newer history in amongst and connected it across. And so these common spaces are off of this major interconnecting walkway downstairs. The TV lounge, the kind of a small cafe, a lecture hall, which I don't have imaged here, and a series of other recreational spaces that all get interconnected. And then we insert this different and new architecture in amongst that, so these simultaneous histories can be seen. And this is a place where you also get to reveal one college against another college. We made these punctures through a common basement wall and a common stairwell wall. It still had to be fire separated by code, but it allows for the living that is going on in Pearson College to be now shared and exchanged with the living that's going on at Davenport College. The two stairs go by one another like this. They crisscross on either side of the wall like this. They don't go parallel one another, but they cross one another. and you look through these portals, you can actually see, students and faculty moving by one another. And here you can see one of those portals through the Davenport stair, looking into the Pearson stair, with somebody coming down that stairwell on the other side. And you can see, we don't replicate their history in the Davenport history either. That history of that new insertion, that stair, was a different language appropriate for Pearson, and the language and refinement of that language for Davenport is completely different. And here you see those portals looking through one stair and another, and the craft, the detail of those insertions. The other thing that we uncovered was, a series of things like plaques, historical plaques, dedication plaques, and so forth that were in odd places and so forth. And one of the things that we did was put them in places purposeful to students, so that they can remember the history of the place, very much as part of the college and university experience, and put it in places that become meaningful to them. Now, the last project that I want to show you is Middlebury College, a commons project, a residential commons project in Vermont. This was the master planning document that we received, a document that identified a series of common buildings that were going to be aggregated into commons, as Cook Commons being one boundary, Ross Commons being another boundary, and then Atwater Commons, this commons that we were being hired for, that had in it 4 existing buildings, one of which was a Edward Larrabee Barnes building, a 1929 kind of French chateau, a building that was built in the 1950s as a freshman dormitory that could be a Motel 6 construction, and another building by a Boston firm, kind of brutalist concrete structure out here. Very disparate architectures, very disparately arrayed in the landscape, a varied landscape of moraine and rock outcroppings that, rolling rock outcroppings, not as soft as the moraine of northeastern Ohio out on this landscape, but much more hard-edged and jagged, of which there was a rift in the landscape right here that we identified. And then the major dotted line is a major campus path going from the new Science Center up at the upper left to the main campus on the lower right. And one of the things that we do in these projects is really speculate on a variety of circumstances and strategies. And in this particular case, we came up with about 25 different strategies about how you can array the buildings on this particular site. From stringing them along, such as this one up here that tried to tie the existing dining hall into the process and took the 2 residence halls and put them essentially like a string of pearls, along a kind of path, but it never really engaged the landscape in any kind of way, never really made a common space, to the one that we ultimately designed and built, that took 2 linear buildings and kind of staggered them, making a kind of Vermont green, and then it's placing a very special building outside of that context as the dining hall and common space. So here you see the existing plan, here with this rectilinear quadrant. Well, the master planners just suggested that we stick a simple bar building across the back edge of that quadrant and call it a deck. And half of the students would have faced in toward the college, and half of the students would have faced out of the college, and neither of them would have had, an understanding of what went on with the other. Whereas all the other buildings look into the college and out of the college, and all the students participate both ways. So our proposal basically took those 2 buildings and made suites out of arrangement so that the bedrooms were on the outside of the residence halls, and the living rooms were on the interior public court of the residence halls. This interior green right here, and arranged them in a manner of fashion so this irregularly shaped green now became Atwater Commons landscape. And the Edward Larrabee Barnes building, which escalates down the hill, echelons down the hill, in a linear fashion, and the kind of centrality of that chateau building right here, and the irregularly shaped L-shaped space of the smaller building, then were drawn together through a path that went out to the master's house, through the landscape, and through our dining hall, tying this landscape all together. And what we suggested to the college is that they basically turn this building into a different kind of program space that would no longer be common spaces anymore, which they agreed to do. So this is a larger diagram of that plan, showing how those buildings basically follow the two ridge lines, framing this rift in the valley. The topo is high in the center of this, falling away toward the north, or toward the top of the plan diagram. And then this elliptical dining hall that has a green roof, a planted roof on it, that has a cut, a rift in it, that is intrinsically connected into the landscape and out to the master's house. So here it is finished. These are stone buildings. I'll talk a little bit about the stone in a moment. But these two buildings, have a slight, bend in them, that follow the rift. And they're slightly staggered from one another so that students don't look in each other's rooms. The stacks on the front and the back are for natural ventilation. These buildings are not air conditioned. Those stacks, which would have been used for fireplaces in buildings, on campus, are now used to ventilate the structure entirely. We work with air on this particular project. And then each of the entries, these vertically organized entries, have a canopy, a bench, and a portal that you enter off the major campus green, looking south. This is what it looks like from the science building, looking into the Vermont landscape. You can see the Edward Larrabee Barnes building, a series of gamble roof buildings that step down in the landscape. Ours wide out in the landscape and gain that extra story at the end. And then the stonework came from Lake Aquarium, Lake Huron, on the front side of the building, which you see in the coin or the right-hand edge of the left image. That whiter stone is a limestone that was hand-dressed. And then the grayer stone is a recycled granite stone that was crafted on site. We had the stonemasons actually lay up uncoursed, excuse me, a series of sample walls, and we approved that sample wall with them. But these are discarded gravestones. What they are granite headstones that are made for the federal cemetery program for World War II and Korean War veterans and so forth, Vietnam veterans. But they're discarded. They've made a mistake in the name or the date or in the religious symbol that goes on that particular headstone, and they've had to discard the headstone after carving it. So we bought all of those headstones and then have used them inside out, turned them inside, and made this rubber wall out. So the buildings used recycled materials and naturally harvested materials throughout as part of Middlebury's agenda for these buildings. These are blind windows here to relieve some of the ends of the facade. Here's the edge of the rock outcropping, one of the and the building bending against that on the bedroom side of the structure. A more frontal view of the portal leading into one of the common spaces, and then into the vertical entries, showing the window pattern. A view undistorted of the south view of one of the residence halls, the bed in it. A view at dusk looking into the library and into the common space as you come in, and then a view of each of those entries are codified by the canopy and the column, and then the bench. And those simple elements just make up a language that then are carried forward throughout the buildings. The inside space of the library has a ceiling that fractures the acoustics in that space, makes it a quieter space, and is unusually lit. And then the dining hall, which is an elliptically shaped building, has a large stairwell and fireplace component, which kind of anchors it to its place. The lower level and one of the acoustical walls of the building are Gabion walls. They're wire cages filled with rock that was blasted out of the site. The stairwell that walks through that particular building makes the rift in the building, looking both ways, has a view into the dining hall as you descend on the left, and as you arrive back from the master's house, coming up toward the residence hall, you have a glimpse toward the green in the residence hall. And then a view kind of elevated from that path along the Gabion wall, looking at the curtain wall and the exterior wall of the dining hall from the outside, and then that view at night at dusk. The dining space, the kitchen is downstairs, and the server is upstairs with the dining hall. The dining hall is essentially one big open space that is moves from about 8 feet high at the entry to about 21 feet high out of its highest tip in this elevation here. And the curtain wall is a Duratherm curtain wall, wood wall that is pleated. It moves and travels. It is kind of agitated, so it's not a smooth wall, but has a lot of fractures to it that were designed three-dimensionally. And the combination of that wall and the exterior colonnettes and the interior columns, and then the larger columns that hold up the roof on the inside of the dining hall, all form a kind of forest of structure that is an extension of the landscape to the outside of this panoramic window. This is a view from the servery, looking back at those major structural columns, then out toward the exterior columns of the window wall and out into the landscape. A view to the excuse me, the portal entry. We have these skylight cones that come into the space that expand the cone. The skylights themselves are only about 4 feet in diameter, but they expand to be roughly about 8 feet in diameter. So, and they're painted with a very bright color. So you always have a sense of light coming into the space, and then a kind of detail of that exterior wall. And then last thing I just want to say is, if you don't have a copy of Refabricating Architecture in the library, I'm glad to read it. Thank you very much. If there are any, you probably want to go get something to eat, or Wednesday night, it's a beer. I'm going to speak up. Maybe you can't post that. Go ahead. The question is, if you didn't hear me, is how through mass customization and mass and offsite construction do we, with materials and assemblies that are coming from a variety of places, maintain the connection to the site that we've shown in the Military College project, which is obviously intrinsically rooted to its site. I think that happens through first planning. And yes, while it looks like it might pick up and walk, primarily because it's on stilts, and it has to be on stilts, because otherwise, in storm surge, it'd be washed away. But another way to look at those stilts and those pilings are, they're the extensions of the trees, that existed, on that site at that particular time. I think it's really through, as much